Hi, so let's begin to solve the 231st problem, power of 2. It's a type, it's a problem from topic of bit manipulation. Yes, it has some many different solutions, but I would like to tell about how to solve it using bit manipulation. So the problem states that an integer n is given and we should return true if it is the power of 2, otherwise we should return false. So he's written the formula: n is equal to 2 to the power of x. Let's try to solve it. So for example, 1 is it is 2 to the power of 0. 2 is 2 to the power of 1. 4 is 2 to the power of 2, and so on. Let's check what a boundary is. You see that n might be negative, might be 0, and might be a positive number. We know that we're interested only in numbers that are more than 0. We're only interested in positive numbers. That's why we can directly write here's a statement: if n is less than or equal 0, then return false. Here's the first statement. So we return false if numbers are negative or equal to 0, because it's impossible to get negative or 0 using 2 to the power of positive number. It's not possible. So now how we can check whether this positive number is a power of 2? So let's see what are numbers one that's written in bit notification. It will be written something like this: 1 2 3 4 5 7 8. 2 will be written like this: 0 0 0 0 1 0. 4 will be written like this: 1 0 0, and so on. So as we see, only one is changing its place, other are all 0. So we can tell that if we check every bit in binary representation, and if it has only one 1, it means that it is a number of power of 2, because if I add here 1, it means that it will be 4 plus 1, it will be 5. So there are two ones, that's why it is not number of power of 2. So we can write an algorithm is to check every binary number in binary representation, and if there is one, we may count it, and if after checking there is more than one, then we return false. If there is only one, then we return true. It's one solution, but there is a more effective solution. If we subtract 1, for example, from this, we have it equals to 4. If we subtract 1, it will be like this: 1 1. It equals to 3. You see that this 1 became 0, and all this 0 became 1. It doesn't matter what, we may choose this number, and minus 1, it will be something like this. So it's 1 2 4 8, it will be 8, and it will be 7. How can this help us? If we do AND operator, we AND this number with this number, we will always get 0 0 0 0. And if we get 0, it means that it is number of power of 2, because if there was 1 and we if we had 1 and we subtract it, we will get something like this. 0, 1, yes, something like this. And after AND operation we will have this 1. It means that it must be 0, but there is 1. That's why this number is not power of 2, as we see. So we should subtract from this number 1, make an AND operation using AND operator. If answer is 0, then it means it is 2 to the power of number is 2 to the power of 2. Number is power of 2. So we just return n with AND operator n minus 1 equals to 0. So if it is equals to 0, it will be true, otherwise it will be false. Let's check. Let's submit. So we get an exception. It's faster than 97% of Java online submission. So here it is. We solved this problem using bit manipulation.